This this setup I have is much easier for me. Anyway, I know that doesn't mean anything to you all because you weren't here in the past, but all right, I'm gonna shut this down. Note to the wise: do not fall asleep watching creepy and scary TikToks, because then you will dream about it. Oh man, I was waiting for you guys this morning, and on YouTube. Let me see. Here it is. Share my screen, and I fell asleep to creepy and scary TikToks, and so all in my dreams, I'm like experiencing all this crap. I'm like, crap, man. I woke up, I was like, why do I feel so weird? I was like, oh, because I fell asleep watching that. So yeah, that makes a lot of sense. Okay, I think we're good there. I think all of this is good. I can see my captions. I know we are live streaming, so I'm gonna let all that be. And I'm gonna do one other thing. We'll go ahead and hop over here. Let me change my view. Single page. Give me a moment to do announcements. Morehouse. Let's switch this one. Okay. Can we get rid of this? Okay, looks like we did. All right. I think we're ready to rock and roll. So I'm gonna just kind of leave this over here. All right, so I know that you guys can get in. Let me see. Just normal announcements. Nothing. I can't think of anything other than we're just kind of going to the next progression. So hopefully everybody has gotten access to Pearson. Keep in mind that with our assignments in Pearson, we get unlimited attempts. The system is set to take our highest score, and there's a nominal late penalty. There's only a 5% late penalty. All right, so if you've missed these first couple assignments, you still got plenty of time. You can still earn up to 95% on homework and quizzes. It's practically nothing. It's like a fraction of a point. All right. So it's not, you're not going to be missing much. You just need to get the assignment submitted. You just don't want things to pile up. It becomes an issue like when we start missing exams and we start missing excessive amounts of assignments, right? I have had students that like.
That's actually that's easy to remember that. Yeah. Yeah, he left.
I might use. I think it'll be okay. I was thinking about using my headphones. I guess I need to go back and check and see how the audio is, and I need to organize and stuff. But anyway, so yeah, so we'll just kind of go on with the next topic, right? So this week we're just going to focus on section 1.2 lines. Another thing is just kind of be careful about being lulled into like a false sense of security, because these first couple of sections are fairly light. So you have a question? Is there a question? Got some questions now? Okay. Yeah. Yeah. So just as long as the main thing that I need, again, that everybody's showing up to get their attendance credit. I know I've had a few people fall into that boat of missing attendance, and then they got booted. So you just don't want to be in that boat, because sometimes it can be a little bit challenging getting back into the class. Sometimes you're not able to get back in. The best thing is just show up and zen out, and at a minimum, and then so as long as you're getting your attendance credit and submitting your assignments promptly, those are the main things that we're looking for. As usual, if you have questions, feel free to unmute yourself or type in the chat with a Q&A. It'll be really nice if I can get this Q&A working in my other account, but this is fine. At least it works here. So, and with that, let's just kind of go ahead and get the party started. And so, like for today, we'll be doing a live lecture, and then on Wednesday, we'll go through as much of the homework together as we can. So we're continuing chapter 1, and we're going to be working on section 1.2 lines. We have a few objectives. 1, find the slope of a line. 2, write the point-slope form of the equation of a line. 3, write the slope-intercept form of the equation of a line. 4, recognize the equations of horizontal and vertical lines. 5, recognize the general form of the equation of a line. And 6, find the equations of parallel or perpendicular lines, right? So with that, hopefully each of you are creating or building your own notebook that contains a copy of the lecture notes, right? So remember, you can pull a copy of these at the end of each session. you can find it in Blackboard in the box link. So open up our main folder on Blackboard. You're going to see a folder that says box link, and you can find a copy of these PDFs in that link after each class. And also you have access to like my other college algebra 1 courses as well. You guys are all working on the same thing, so you can pick whichever one you want to work to use. There was something else I was trying to get to it, but it's okay. Oh, so yeah, in your notebook you have a copy of the note, a copy of the homework. All right, I might start using it. You guys okay? You keep me. I'm getting. So, if you have a question, Mr. Solomon, going once, going twice. That's okay. All right. You have a copy of the notes, a copy of your homework, right? Properly labeled, a copy of each question, all supporting details, final answer in the box. And then kind of towards the back of your notebook, it's recommended that you have like a formula sheet, right? So I was saying that because we have a lot of formulas in this section that we pretty much use the entire time that we're doing mathematics, right? These are, we use them a lot, right? So we have some definitions. Since the graphs of first degree equations in two variables are straight lines, these equations are called linear equations. We measure the steepness of a line by a number called the slope, right? So, lines, the higher, and so the slope of a line, the higher the slope, the more steep the line is, right? A slope of 0 is a flat horizontal line. And as you approach infinity, those slopes get closer and closer to a vertical line, right? So the rise is the change in the y coordinate between points, and the run is the corresponding change in the x coordinates, right? So the slope of a line is what? Rise over run. Now, when we're trying to determine whether a line is positive or negative, we always trace it from the left to the right. So, like for instance, on the graph from the left, if we trace it from the left to the right, notice that the graph is going up. So that we would say that line has a positive slope. The one on the right, as we trace it from the left to the right, it falls down. So we would say that one has a negative slope. Okay. So whenever we're trying to determine whether the slope is positive or negative or increasing or decreasing, we always do that from the left to the right. Okay. And so if you have your formula sheet, this is one that is recommended to update with your formula sheet. All right. So this is our slope formula. Slope is going to be the rise over the run, which is our change in y over change in x. And so the formula is y2 minus y1 over x2 minus x1. The slope of a vertical line is undefined. Okay. All right. So you can either screenshot that. Again, you'll get a copy. A copy will be made available at the end of class. But if you have a formula sheet, that's a great one to add. The slope formula, add to your formula sheet. Let me see. Sketch the graph of the line that passes through this point. Find the intercept and the slope of the line. The intercept and the slope. I don't know what to do it. What have we talked about? Okay. Okay, we got the slope. Let me see. Find the intercept of the line. Because I'm trying to think of how to do this without the slope-intercept formula, because we haven't talked about it yet. I guess if we're just doing it in a graphical sense, we can look at the graph. The trouble with graphing is if you're not exact, then it'll throw things off. Maybe, you know what? I think I'll do a demonstration. I'll showcase, I think I'm going to do decimals. So I'm going to try decimals, see if we can get that working. So I'll put it like here. That's fun. I'll close all these tabs. Okay, let's go to decimals. Just as a demo, all right? Open the graphing calc. So this what Desmos is a free virtual graphing calculator. You guys can use it. So if I go to open a graphing calculator, and let me see, I'm trying to think of how I could do it on here though, because I know I can plot points. Let me see if I do like let's see if we can plot these points. So then we have what, 1 comma negative 1. So enter. Can I see the point label? Okay, can I adjust a little? Yeah, just a little. Oh, and I'm working on an iPad here, so. Okay, I'm not seeing how to adjust the label. Or probably appear in settings. Copy. There it is. Okay. Okay, well, I just wanted to see the options. I don't really care about it. Okay, and then let's plot the other one. Let's see if we can use this. So 3, 3. Now, I don't know if we can draw a straight line. What's the slope? We got our points. It's plotted the points. I'm just trying to see if there's an option to draw a straight edge, and I'm pretty sure there is. Can I? Let's see, what else do we have? Folder, image, expression. Okay, I'm not seeing the option here. Okay. Okay, we can at least do the slope, sketch the graphical line that passes through this point, and then, if we had a straight edge, we would just connect it. We could put the equation of the line, even though we haven't talked about that. That's what I was trying to avoid. Find and interpret the slope of the line. That's fine. We can at least go ahead and do the slope. So, we're gonna do the slope. Slope formula. So the change in y over the change in x. So that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay. And then also what I like to do is when I'm given an ordered pair, I like to automatically label them. So I'll go like x1, y1, x2, y2. Okay. So then our y2 is like 3. Our y1 is -1. Notice I put it in its own set of parentheses. x2 is 3. x1 is 1. So on top, we have a double negative. So that becomes positive. So then on top, we get a 4. And that's a 2. So it looks like the slope is 2. All right. Mhm. All right. I was avoiding. Or you know what I can do? I know what I can do. Where'd it go? So if I go like this, no, it's not there either. So another thing that I can do, I just realized, I'll just take a screenshot and use the screenshot. Okay. Use this. So what I ended up deciding to do was just like using the screenshot or using a capture from Desmond. Oh, didn't mean to draw that, but that's okay. It's a little bit smaller than I would like. Let me move some stuff around just to try to make it a little bit more visible. So I'll move like this. Not there. I may have got the wrong one. That's okay. Okay, that's not gonna work for me. Sorry, guys. All right, we put you right there. I think it's going to shrink that down, but that's okay. I'm just trying to create some space. Okay. So a little bit lazy, but I mean, because instead of like creating a graph paper and this, that, and the other, I was like, oh yeah, I can just use a screenshot, right? So now we have our plots pointed. I probably should have gave myself a little bit more space. Let me see. I think I can go like there, like there, like there. We can go from here. Let me see. It should be like there, right about there. Okay, I think that's decent. And it kind of went off the graph. We kind of ran out of space. I probably should have changed my viewing window because it's not showing the y-intercept. Sketch the graph of the line that passes through this point. So, okay, that wasn't too bad. Find and interpret the slope of the line. Okay, sketch the line. Okay, yeah. So that's all we did, right? I wasn't sure how to do this without using the equation in Desmos. So I was like, okay, well, if I take a screenshot, so this is going to be the graph of the line. We just plotted the 2 points and just connected them with a straight edge. And then the slope, we got a slope of 2. So that means that every time we go up 2 units, we go to the right by 1 unit, right? So a slope of 2 means we'll go up 2 and over 1, up 2 and over 1. Okay. Wasn't too bad. They eventually came together. So find and interpret the slope. The graph of the line that passes through these points and is sketched here, and we got a slope of 2. Okay. All right, let's keep going. The value of y increases 2 units every 1 unit increase in x. Yeah, that's fine. Let me see. Scanning a graph from left to right, lines with positive slope rise and lines with negative slope fall. So I think we said that earlier. The greater the absolute value of the slope, the steeper the line. The slope of a vertical line is undefined. I think we mentioned that. Well, we're seeing it now. So the slope of a vertical line is undefined, and the slope of a horizontal line is 0. Okay. So if a line has a slope m and passes through the point, then the point slope formula of the equation of the line is given here. Okay. So this is another formula to update with your formula sheet. This is called the point slope form of the equation of a line. We tend to use this when we're given a point and a slope, right? The way I like to remember this one is I like to start with the slope formula, right? Like if we start with the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right? And then if we use some algebra where we move the denominator to the other side, so we multiply both sides by the denominator. Same thing over here. And then, if we simplify, so these are going to cancel. And if we drop the 2's, then we essentially get this, y minus y1 equals m times x minus x1, right? Which is this guy. So so with the slope formula, and if you can digest or process this like manipulation, then you really get two formulas for one. If you know the slope formula, you can move that denominator to the other side and drop the 2's, and then that'll generate the point slope formula. I'll do a showcase or two with the point slope formula. I tend not to use this one though. I had a student in the past. I used to kind of and it's nothing wrong with using it. But then I had a student that was like, he solved the same equation, but he only used the slope intercept form. And then I looked into it and he was correct. So oftentimes I feel like the y equals mx plus b, the slope intercept form is a little bit easier. We're going to talk about that momentarily. Again, let's go ahead and do a showcase of an example or two of this one. So find the point slope form of the equation of the line passing through this point with that slope, and then solve for y. Okay. So point slope again, y minus y1 equals m times x minus x1. One of my professors will say, every time you use a formula, write it down. That would help to ingrain it in your memory. That's how we memorize a lot of it. Every time we use it, just write it, and then it becomes second nature. And then I think we only have 1 point, so I'll just label it x1, y1. Okay. So then if we plug in the corresponding information, so let me see, we have y minus, now y1 is -2. Notice my use of parentheses. My slope is what, 3? Okay. And then x minus my x1 is 1. Okay. Then it asks us to solve for y. So we got a double negative. So then that becomes a positive. If I'm going to go ahead and solve for y, I'll distribute this guy. And then subtract my 2 on both sides. Combine like terms. So then we get y equals, what is that, 3x minus 5. So, and then let me just kind of, usually I put my final answer in the box like that. Sometimes you might see me write my final answer like this. It means the same thing. It's just a way for me to highlight my final result. Okay. So then notice that our slope is 3. When x is 1, 3 minus 5 is what? -2, right? So this point checks out. And we also have that slope. Okay. All right, I think all of that's fine. All right, this one asks us to find the point slope form of the equation line, pass it through these points, and then solve for y. Okay, so I think this is similar to the one we did before with some minor nuances, right? So point slope. Y minus y1 equals m times x minus x1, okay? Now we got 2 points, so I like to label these x1, y1, x2, y2. And since we have 2 points, it looks like we might need to find our slope first. So let's go ahead and write down the slope formula, changing y over changing x. So that's y2 minus y1 over x2 minus x1. Again, this is our slope formula. Okay. So if we plug in the corresponding components, 7 minus 1 over, let's keep doing that, that is irking me. Discharge, I don't know, it's just, you know. 7 minus 1 over 3 minus a -2. Okay. So that's going to be a 6 over 5. This is our slope. Okay. So now we have a slope and a point. Now we can use the point slope formula. So that's going to be y minus our y1 is 1. Our slope is 6 over 5. X minus a -2. So I'm just going to go ahead and write it as x plus 2. And then it says it asks us to solve for y. Okay. Will that make it any easier? Okay, so what I'm going to do, I'm going to clear out my fractions instead of working with that 6 over 5. I don't know if this is going to help or not, but I do want to kind of do the showcase. So to clear out the fractions, I'm going to multiply the left side of the equation and the right side of the equation by the least common denominator, the LCD, right? So I'm going to say this side times 5, and I'm going to say this side times 5. Okay, on the left, when I do this, I have to distribute. On the right, this is going to cancel this. Okay. So then, we're going to have to undo it, but I feel like this is still easier to like navigate than keeping that fraction. So we get 5y minus 5 equals, and I'll go ahead and distribute the 6. 6x plus 12. Okay. So then let's go ahead, move our 5. So we're going to add 5 to both sides. 6x, what is that, plus 17. And now, to finish it out, we divide both sides by 5. We get 6 over 5x plus 17 over 5. Okay. So even though we still had to divide out that 5, I still felt like it was easier to navigate. Just because like if we kept that fraction, then we would have been multiplying 6 over 5 times 2. I know that just kind of, and then we'd have to add 1 to 17 over 2. It just gets, or 17 over 5 or something. Anyway, 6 times 2, 12 over 5, right? It gets a little bit more dicey. So I just did it the way I felt like it would be the most simple. Okay. And then another good idea is to confirm that these points work. When x is -2, that'll be what, a -12. We get 5 over 5, which is 1. And then when x is 3, 18 over 5, 28, 35, 35 over 5, which is 7. All right. So that would take a little bit of effort. you know, and we could use our graphing calculator to check that, but I'm just going to leave that for now. Okay, so I think we got the same slope, and we got the same result. Let's see, they did it where they kept the fractions, right? So they plugged in a slope, they plugged in x1 and y1, and then here, notice they had to distribute the 6/5. So I gave them -18/5. Oh, and they chose a different point, right? I think we chose the other point, and they chose the second point. They still got the same result. All right. That's interesting. Anyway, let me see the time. Okay, I think we're okay. Find the point slope form of the equation of the line with this slope and this y-intercept b. Oh, okay. Find the point slope form of the equation of the line with a slope m and a y-intercept. Okay. So basically what they're asking us to do here is we're doing point slope form. So that's going to be our y minus y1 equals, because it's plugged in. Y minus y1 equals m times x minus x1. And the point that the y-intercept of b is going to be the ordered pair 0, b, right? So that's going to be our x1 and our y. Okay. So then we're going to have y minus b equals m times x minus 0. So anything minus 0 is itself. We add b to both sides. Ultimately, we get y equals mx plus b. Okay. So this is actually, it's called the slope-intercept. We see it here. So if you have a formula sheet, this is another popular one, okay? So let me do a quick summary. Whenever I'm working with lines, there are 3 equations I generally like to have ready to go. So again, whenever I'm working with lines, first I have my slope formula, y2 minus y1 over x2 minus x1, okay? So, and again, that's our slope formula. Put it here. Slope formula. Okay. Then we have our point slope formula. And that's going to be y minus y1 equals m times x minus x1, okay? And then finally, this last one is called slope-intercept. So I'll kind of write it here for now, and I'll move things around. Slope-intercept. And that's our classic y equals mx plus b, right? Give me a moment. I'm going to resize these guys. But yeah, whenever I'm working with lines, I try to have these 3 ready to go at my disposal. Let me see. That's decent. That's decent. And so, and then it's just a matter of just being able to flow between these guys and, you know, using the appropriate one. Again, like, you know, we have this point slope. Again, I tend not to use it, but I still have it ready to go and I use it as needed. But honestly, if you know, like, if you're able to do the first one and the last one, those are the main 2 that I kind of like go between. Okay. All right. So we got a solid 20 minutes, 15, more like 15. I graph the line whose equation is given by this. So in the slope-intercept form, notice this is in the form y equals mx plus b. Okay. So in this form, this is the easiest way to graph a line. We have our y-intercept. Let me see. Just do it like this. Space. Okay. A little bit dense, but that's okay. We don't need that much. Okay, so we have a y-intercept of 2 and then a slope of 2/3. So like, what if we made, feels like they changed this font. Maybe this is our origin. because I can't even see it. It's too small for me. Let's see. Normally I use the one that looks better. Okay, now it looks different. I knew something was off. I was like, that was irking me. Okay. Anywho. So we'll say this is our origin. We'll go, let that be 1, 2, 3, 4, 5. Okay. And then let's go 1, 2, 3, 4. That's good about there. So say this is our positive x in this direction. Can I change this? And our positive y is in this direction. Okay, this is x, this is y. Okay. So we have a y-intercept of 2, so that means across the y-axis. And again, my label, this is like 0, 1, 2, 3, 4, 1, 2, 3, 4, 5, -1, -1. Okay. So it has a y-intercept of 2. We'll start here. And then the slope tells us how to get to the second point, right? So if it has a positive slope of 2/3, that means we go up 2 and right 3. Right? So if we go up 2 and then right 3, 1, 2, 3, we get a point here. Okay. Then we just connect them with the straight edge, down 2/3, down 2/3. So I think it goes from here. Let me see. 2/3, up 2/3, up 2/3. It's a little bit off. Let me just try this again. 2/3, 2/3. I think that's accurate. 2, 3, 2, 3, 2, 3 is here. Why does it look so weird? Okay, that looks a little bit better. Okay. All right. And so ideally, we want to stretch the graph across the entire, stretch our line across the entire graph, right? So we get an image something like this. All we did was plot the 2 points. Again, the y-intercept was our first point. So it crosses the y-axis at 2. It had a slope of a positive 2/3. So we went up 2 and over 3 and then just connected them with a straight edge. We got an image like this. Okay. So for any constant k, the graph of the equation y = k is a horizontal line with a slope of 0. The graph of the equation x = k is a vertical line with undefined slope. Right? I don't know why I couldn't get my words out. I like I said, I fell asleep right before because I was up. I had been up. I'm usually up like early, like in the 3, 4 o'clock hour, and I've been up. But then I fell asleep. I always fall back asleep. Like whatever time I'm supposed to get up, that's when I go back to sleep. And when I'm supposed to be asleep, that's when I'm up. It's been like that for years. So I was like, I don't know. It is what it is. So, but yeah, I'm still a little bit groggy, but it's okay. So again, a flat horizontal line has a slope of 0, and that's going to be y = some number. X = some number is a vertical line that has an undefined slope. Okay. The graph, so y = 2 is going to be a horizontal line through where we have the y-axis where it's y = 2. B is going to be a vertical line through the x-axis at 4. Right? So horizontal line through y = 2 for the first part has a slope of 0. Vertical line through x = 4 has an undefined slope. Okay. All right, the graph of every linear equation where a, b, and c are constants and not both a and b are 0 is a line. This equation ax + by + c is called the general form of the equation of a line. So this isn't really a formula. This is just like a form. So like, well, we'll have the equation of a line. Then we might either put it into this form, or we might be given a line in this form, and we have to work backwards, right? But I still feel like it wouldn't be a bad idea to just go ahead and add this to your formula sheet. Again, this isn't necessarily a formula. This is just the general form of the equation of a line. Ax + by + c = 0. Okay. So find the slope y-intercept. slope, y-intercept, and x-intercept of the line with this equation, and then sketch the graph. Okay. So let me see. Now, I know there's some shortcuts here, but I think that what I'm going to do is just solve for y, and then that'll tell me everything I need to know, or enough of what I need to know. Yeah, we'll do that. So let's start by getting a copy. 3x minus 4y plus 12 equals 0. If I'm going to solve for y, I think I'm going to add the 4y to both sides. Okay, and we'll get, I think what's left on the other side is this guy. Okay. And then divide both sides by 4. So the slope, right? So the slope here is 3 over 4. So what is that? Is that a over negative b? Anyway, so it looks like our slope is a positive 3 over 4. It's one piece of information. Now, when it comes to finding that y-intercept or the x-intercept, I tend to prefer to find the y-intercept first. Oftentimes, it's easier. To find the y-intercept, we set x to 0. And so you should be able to quickly see that the y-intercept, if we set x equal to 0, it's going to give us a 3. Okay. And then the x-intercept, so if we set y to 0 and solve, so let me kind of work it out. I'll work it out over here. So then we got 3 over 4x plus 3 equals 0. Subtract 3 on both sides. Okay. Take a moment. How would you get rid of that fraction? There's a couple of ways you can articulate it, which is essentially the same thing. Just take a moment. How would you move that fraction to the other side? So either, hopefully you're thinking, you can divide both sides by 3/4. But whenever we divide by a fraction, that's the same as, hopefully you're also thinking multiplying by the reciprocal, right? So you can either divide both sides by 3/4, or you could just multiply both sides by the reciprocal. So 4 over 3, so times 4 over 3, okay? So these are going to cancel each other out. So like 4/3 times 3/4 is very easy, and it becomes 1. I think the 3's on the right-hand side cancel, and we're left with -4. So if, no, that was a slope. Y-intercept. So I bet you that divided by that. Negative, anyway. So we got what, -4 comma 0. Okay. So we got our y-intercept, our x-intercept, and our slope. And then the graph. So I feel like the simplest way to graph is using this guy here, because it has our y-intercept and it has our sphere. So say this was 3 here, this is 6 here, and this would be about 4 here. So our y-intercept was 3. If we go up 3 and over 4, we would have our second point here, and then we connect them with the straight edge. And again, this is just like a rough sketch. Do arrows in both directions to signify that it goes on in those directions forever. We got about 10 slides in about 10 minutes. So let me try to wrap this up. All right, that's decent. Okay. The slope, y-intercept, x-intercept. That's fine. Okay. We see the height of a human male is related to the length of his femur by this formula, where all measurements are in centimeters. The femur of Wild Bill Longley was measured to be between these two. Estimate the height So what they're asking us to do, this is 45 and 46 centimeters. Where is it? Okay. So basically we will plug these, like plug 45 centimeters and it'll give us an estimate, and then plug in 46 centimeters and it'll give us an estimate. Okay. So I think what I'm gonna do for this is use my graphing calculator. Okay. Since they gave us the formula and we're just evaluating the formula at these values. So I'll go to my y equals, I'll put in my 2.6x plus 65. And then to call in that function, on the right-hand side of the calculator, to the left of the button that says clear is a button that says VARS. I think that's short for variables. I'm gonna click on that button. I'm gonna go to the right to go to Y variables. I'm gonna click on number 1 for function and number 1 again to call in the function I just typed in. I want to evaluate this function when x is 45 centimeters. We get 182 centimeters, okay? So then h of 45, we got 182 centimeters. We're going to do a conversion in just a moment. And then h of 46. So we did 45. Let's evaluate this when x is 46. We got 184.6. Can't write today. At the time, we got to. Okay. So now let's convert this. Let's see if we can do a conversion here. Let me see, centimeter. Okay. Let's start with like 182 centimeters. I'm going to put it over 1. Now what? I think it's 2.54 centimeters is to an inch. So 2.5, you don't really need to know this for right now. I'm just doing a showcase. 2.54 centimeters, I want to say is 1 inch. Okay. So we can at least convert this to inches. Yeah. So what I'll do is I'll say my 182 divided by 2.54. (182 divided by 2.54). Okay. So we got like 71.65 inches. What's the nearest multiple of 12, right? 12 times 5 is 60, 72. So he's just shy of 6 feet. 5 times 12 is 60. So if we take out 5 feet, 11.65 inches, right? So he's at least 5 feet, 11.65 inches. I think that's right. Right. He's somewhere between that. And then let's do the 184. So if we said 184.2 divided by 2.54, 72. So that's 6 feet, half an inch. So he's approximately 6 feet, give or take, right? So we got this in centimeters and feet in inches. 1 tick mark is a foot, double tick mark are inches. Let's see, how do we do? Okay, I think we got those same results. And then if we convert it from centimeters to inches, approximately 6 feet tall, right? So I think that's pretty much what we got. Let me do a quick scan. It would have been nice to have worked this together. So when we're looking at two lines that are parallel, they have the same slope. Lines that are perpendicular, their slopes are negative reciprocals of each other. In other words, for perpendicular lines, when you say the first slope times the second slope, you get a result of -1, right? So again, parallel lines have the same slope. Perpendicular lines are negative reciprocals of each other. In other words, when you say the first slope times the second slope, you get a result of -1, okay? So I'm going to have to leave this one as as an exercise. The details are worked out on my recordings on my YouTube channel, and that was it, right? I feel like there should be questions, but maybe I don't know if it was light or not. I felt like I was moving a little bit fast, but we got through this, and so then actually, today is Wednesday. I forgot that Monday was a holiday, so we're not going to get an opportunity to go through this homework exclusively right now. Maybe when we're reviewing for the final, I mean not the final, but for exam 1, we'll come back to this and work some examples from here. But for next week, we're going to go ahead and move into section 1.3. Are there any burning questions before we go our separate ways? Let me go ahead and make a copy of this available for you guys. That is not the right folder. 24, traditional. Okay, notes updated daily. Okay. All right. So when this bar finishes loading, you'll receive a copy of anything that you saw me writing. Yeah, can't think of anything else. Again, so next week, again, we're going to move into section 1.3, basically the next section. And if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, gentlemen. And we'll meet back on Monday, same time, same place. Take care. Peace.
Bye.
Yep. I did not check the chat. Chat looks okay. Q&A looks okay. What is this? Maybe did I check it here? Maybe it didn't show up there. I don't know why it's not showing up there. Maybe that was before. Oh yeah.